Tune into this week's Xamarin Show where I have my best friends in the entire world, Tim and Don, on talking about Fsharp and Fabulous and how to get started with functional programming. So tune in. Welcome back, everyone, to the Xamarin Show. I'm your host, James Montemagno. Today, I have two of my favorite people in the entire world, Don Syme himself and Timothy. How's it going, buddies?
Hi, James. Hi. Great to be here. Thanks for being on the show.
Yeah, super excited to have both of you here. Now, we know that all of Don's children are all on the internet right now, so we have this beautiful photo of you, and you picked it, so it's your fault. It's there in legacy forever.
Takes 15 years off me, James. Well, you gave me the choice. I'm going to do it.
Hello. Now, a few people may not know who you are, Don. So let's start with you, Don, and maybe give a quick introduction of who the Don Syme is.
So, I'm the language designer on Fsharp. I've been working in the language design space at Microsoft since I joined back in the late 1990s, and I landed at Microsoft around the time .NET started, and that's been my thing ever since, working on C# and Fsharp all the way through, and we've made lots of good progress on both of those.
Beautiful. And how about you, Timothy?
So I'm a .NET developer from Paris. So I've been using Xamarin for several years now. And I'm also the maintainer of Fabulous to write Xamarin apps with Fsharp.
So people may have figured this out already. We are on a Fsharp craze right now. We're going all Fsharp for the next few episodes. So that is why I brought the experts in to talk about itself, because, I have a good friend, Frank Kruger, who is an Fsharp guru, if you will, and always is trying to convince me on our podcast on Merge Conflict if and why and how I should use Fsharp. And he still hasn't convinced me yet, although I have seen a lot of his code and it's very beautiful. And he tells me that it's impossible to write any exceptions in Fsharp and that his app will never crash because of Fsharp. So I kind of am a believer because Frank uses it. And I've talked to Don many a times, who's convinced me over the years. And I said, I got to have you both on because there's a lot of developers out there that are looking towards like different styles of development. And I think Fsharp brings a unique twist. So I figured, why don't we start at the beginning? And Don, sort of, maybe you can tell us a little bit of where we are today and sort of what is there for Fsharp developers and with Fabulous.
Yeah, absolutely. I'd love to tell you about those things. So shall we switch over to my screen share? I'll share screens. And what I want to do is sort of set the scene on how I got involved with Xamarin and what my thinking was a couple of years ago when I first joined the Xamarin dev team. I have the pleasure of spending 2 years working for Miguel de Casa. Everybody in Xamarin knows him as one of the originators of the Xamarin kind of framework. So I'm going to do just a couple of slides on getting started with Fsharp. There's going to be a lot of people in Xamarin who you may not want to just dive straight in and do Xamarin with Fsharp. It might not be that. You might just want to sort of ground yourself in the language a little bit. And there's just a couple of links for how to do that. This is how simple it is to get going with Fsharp today. Fsharp support today is in the .NET SDK, the .NET Core SDK. You can .NET New Lang Fsharp, .NET Build, and you're off and running with your first Fsharp code. And there's lots of good getting started material. And so if it's been a while since you looked at Fsharp, then just dive in with this and run through the quick starts and the like, and you'll find it's a whole lot simpler than it's ever been before to get going.
Yeah, that's beautiful. And also because it's probably important too to start with just the core language, because Fsharp is a functional language. So it's if you're a C# developer, I'm assuming it's similar, but then also drastically different at the same time.
There's lots of things that it shares in common. There's so much shared knowledge between the two. So that's one of the great things. You can switch over to this functional programming style and functional programming methodology, or functional first methodology, without diving in and having to completely change framework and the like. So there's a lot you can reuse as you switch across. Just going to say we've been working a lot on Fsharp 4.5, 4.7. We're working on Fsharp 5.0 at the moment. And so lots of good things coming through. And it's very common to use Fsharp for the backend. If you want a starter for how to do that, you just go to the Giraffe project. This uses ASP.NET Core under the hood. You can make fantastic server-side services using Giraffe web servers and the like. And and it's super all the performance improvements that you get from ASP.NET Core and .NET Core 3.0, and it's a really wonderful way a wonderful place to be using F#. But we want to talk about F# for the front end, and in the context of mobile and Xamarin. And there's a photo of me, which I posted in, and I'll skip that on over. So the thing about F# for the front end, and this is one reason why I was super excited at the opportunity to move across and work with L for a while in the context of Xamarin, was we never really tackled the problem of having an opinionated version of front end programming with F#, either mobile programming or even web development programming. So F# historically, we'd always said, yeah, use F# on the server side, use it for the cloud, use it for compute engines and the like. But, the front end, your app, do it in WinForms, do it in WPF, do it in C# and hook it in F# as the backend. And at some level, I'd always kind of known this had been underselling F#. But on the other hand, the whole chains necessary to do the whole front-end development were often extremely complex. They're extremely complex frameworks. They designer tooling on top of it. And so, we couldn't kind of justify making F#, a first-class front-end experience, especially when the front-end space was actually developing itself over time, in forms to WPF and UWP and things keep changing in that kind of space. Some amazing things have kind of happened, and the whole world of UI is kind of developing. And this is a situation as I saw it a couple of years ago when I landed at Xamarin. And on the one hand, we've got this, well-established MVM or MVVM kind of approaches to doing UI development. And GDK is kind of a version of that. We've got WPF, we've got the Xamarin frameworks, the native ones, got UWP, got Xamarin.forms. And they're all kind of in this space, yeah? And you can do F# with those. They're good code samples. You can do F# today with Xamarin and the other ones. And they're not bad. F#'s a good language there. It's actually quite a strong object language as well. But it's still not that functional beauty and that we had that I was kind of looking for in it. And then in the last 3, 4, 5, 6 years, depending when you count it from, there's been this move towards a very different kind of architecture for doing the whole front end. And it's much more suited to functional programming, and it's much more based around information flow. And so these are some of the frameworks you'll see over this side. We've got React, got a lot of these elements in it. You've got Redux, Flutter. There's a wonderful web programming framework for F# called Fable. And it's got Fable is a compiler, and the framework is called Elmish. And that lets you do MVU on the web client side. And that was very influential on what we were doing in Fabulous. So the whole aim of what we're talking about today is really to take the core ideas of Fable and make them work in the context of mobile app development. And Elm is a language and an approach to web programming that's also very influential in this sort of MVU kind of space. And that's where you're doing a very pure form functional programming for your entire web client side. Okay, so that's all cool. So over on the left, this sort of MVVM, you get lots of O, you get lots of mutable models. They're quite complex. You usually have a second markup language. It might be XAML, it might be static, or whatever else for GTK. And you get this kind of complex designer tooling on the right. And over on the right, you get this much more functional programming, simple declarative models, this sort of, you layer a dynamic UI, and the view is usually done in the same language in a DSL. Most of the view, not all of it, most of it. And the tooling tends to be based around live coding much more than the sort of designer stuff on the right.
So on the MVU side of things, you're saying here that this is more towards like, hey, I'm building my logic all in F#, and I'm building all of my views in F#, and it's this sort of not like tightly coupled, but there's less like gobbledygook in between them in a way.
the key thing is actually how information flows in the system, and so let's take a look at that. So this is the sort of the core of the difference. Over on the left, we've got an MVVM, and we've got the usual setup. We've got the view, we've got some kind of data binding, got a view model, coding object, and then we've got some business and logic data behind the scene. And then when updates come in this system, because everything's done in this mutable object way, you get the data binding hitting on the view model, making an update, the view model goes and perhaps gets some notifications or information back, and then pushes some changes back to the view. You get two-way bindings and so on. And so information is kind of flowing back and forth through these mutable objects all the time. Over on the right, it's a really different thing. You have a model, which is going to be a functional model, an immutable data. And it gets rendered to a view, which is also a piece of immutable data. Now that render is going to just be a function. It's just going to be like, here's my core model, here's my description of the view. It's like almost like generating your HTML that you want, the exact HTML at any point in time, or the exact DOM elements or the exact view elements. You just render them and you get a description of the view. And in the view, of course, you click a button or something, you get a message, and the message gets through the update logic. And the update logic creates a new model. It's a immutable piece of data. You re-render the view. You run the whole view computation all over again. And crucially, everything is essentially functional in this setting. Everything is just information flow. So if you want to work out, well, what does clicking a button do? You see, well, what message does it produce? So well, what happens when we get that message? Well, what's the model? What's the way the model is what's a new model that's generated for that message? Once you get a new model, what view do we get? You just rerun the render function, and you can have a look. And so they're the two very different, and there's actually a reason, if you notice, over on the left, you've got lots of objects of mutable state, and over on the right, you've got this circular information flow. And if you actually just go back and look at the logos, you'll actually see that in the actual logos about how things go. Over on the left, you see like GTK, that building blocks, objects. Over on the right, things like Flux, the information is flowing around and around in circles. And that's actually really takes quite a long time to get used to that, and it's also it changes your perspective fundamentally on how user interfaces can be put together.
Got it. Yeah, I've been in a long time in the MVVM space, and I think the first time that you were talking MVU to me, and Frank was trying to talk to me, and Brandon was also trying to get me into this space, and James Clancy, and there's a few people that are really into the MVU style. I think that when I first saw like a button click to sample, which is like the standard sample, and sort of how easy that was to actually still remove that tightly coupledness of it, it was kind of mind-boggling to me.
Yeah, so let's say we put that in the code. We have a type, which is a model. This is F# code. This is pretty much this is pretty much the structure of every single component MVU app. It doesn't matter whether you're doing Fable and Elmesh on the web. It doesn't matter if you're doing F#, Fabulous, or pretty much they all kind of look like this. You have a model, you have some messages, you have an initial model, you have an update function, and you have a view computation. And making that a bit more concrete is the button. The message is the button has been pressed. The initial is that it hasn't been pressed. You have an update logic. If the button is pressed, then update the model. And finally, we have a view down here. And notice the whole view is dynamic in the sense that if the model is pressed, we get a completely different view. We get a label. And if the model hasn't been pressed, we get a button. So you know by looking at code that as soon as that button is pressed and the message is processed, then the view is going to change to a label. You can just read off the structure. Now, nothing has been mutated here. This obviously all hosted inside some system that is doing the view recomputation and making everything real. And that's really what is all about. And I think that's the info I want to give to MVU. It's all just functional programming, and that's just UI becomes calculation. Because functional programming is really like Excel, right? It's just calculation. Yeah, everything's a formula. So everything becomes calculation and not state. Everything becomes data and information flow rather than control. It's not about control logic. It's not about asks. It's not about anything you find under the doc control namespace. You can forget about most of that stuff because you've just got data and the views get recomputed. And one crucial part of that is that you're actually doing a VDOM kind of thing. You're generating a VDOM at every stage, and then the machinery goes and works out a delta actually applied to the DOM. It works out the delta with, you removed that button and replaced it with a label. And it'll reuse controls. It'll do the minimal set of updates that are necessary for the actual DOM. And so your user interface is sort of this incremental kind of computation.
Got it. So there's probably like the mistake, which is when you see that there's this update function, you may think that, I'm basically wiping out my entire UI and then re-putting in the entire UI, and that might be a performance hit. But what I'm seeing here with this sort of VDOM, if you will, is that no, it's really like it's smart enough, the framework is smart enough to just remove the thing and put in the thing, or just make the change to the property, sort of like what we're similar with MVVM in a way of like a binding, like it is visible, or a change, like it's updating the smart things. Is that correct?
Yeah, that's right. So it is rerunning the view function. So it is regenerating these VDOM elements. And in our second installment, we can talk about how we can even get rid of that and make that fully incremental. And that's more, but you rerun the view function and you can make that efficient in a whole lot of ways. So you don't recompute various parts of that. And then there's a diffing process, which is, again, there's various ways to make that process, to make that efficient. And it is like a lot like what they've had to do with XAML over the years to make sure that you don't, that binding logic is done efficiently.
Yeah.
And you get these kind of minimal updates, exactly like you were describing. So performance is something to keep in mind. These tend to be information apps, but not super high update rate apps. So you can do animation separately. We can talk about that as we go along. But the key thing is that you'd be expecting processing like messages like 10, 20, 100 messages a second, but not like thousands of them. Okay.
Got it. That makes sense. Beautiful. Yeah, I mean, it makes a lot of sense to me, and especially if you're already doing functional development, it sort of seems like it's a natural fit. It's a
really beautiful fit, and it's especially beautiful for where UI has to be dynamic. So a lot of what I see UI developers doing is kind of struggling with effectively trying to maintain all this state all the whole time. And this just actually makes a lot of things disappear, makes a lot of concepts disappear as well. XAML, when working with XAML, it's got a lot of advantages. But because it's kind of static, you need these things to make it dynamic. Like you need all these behaviors, and you need these converters and the like, and various flags on the controls to make them appear and disappear, and then you always struggle. Templating as well is to kind of make things dynamic. So you're often fighting against the static nature of XAML, and in this kind of setting, it just becomes really natural and fluent to produce lists of varying size, or produce grids of changing kind of size. So a lot of things kind of drop out in the, just even this little example of this kind of this kind of just drops out naturally. I didn't need to make the button appear or disappear or have the kind of visible properties being set on the thing. It just gets managed for us. Okay, cool. Yeah. But we've got to talk about making this real now, because we want to talk about Fabulous. This is kind of setting the scene for why I got involved. And, we were wanting to make sure we had a good stream of innovation in the Xamarin space when I came to work with Miguel, and to make sure we were doing lots of interesting things. And Fabulous was one of the things that came out of that. So I'm going to let Tim describe what we've been doing, where that led us.
And to get started, you can go to the GitHub repository on github.com/fsproject/Fabulous. So you have pretty much everything about Fabulous here. So what Don has been describing, it was Fabulous for Xamarin.forms. So Fabulous is not necessarily linked to xamarin.forms. It can support other frameworks, but today we will look at xamarin.forms. So we basically just have what Stone showed us. So the model, the messages, the init function, the update function, and the view. So that's all of what's required to get a functioning app. And you have two flavors. So you have the dynamic view flavors, it's like this. And you can also use the Fabulous static view that allows you to write your views in XAML, so, with bindings, with setters, styles, and everything. But the rest will be in Fsharp. So that's two options you have.
So you kind of get the option. Like I've gotten a lot of developers that are like, hey, why can't I just write normal XAML and Fsharp? And I'm always like, I'm pretty sure you can do all that in Fabulous. So you still actually have the option of doing XAML if you're like, I love XAML, because I love XAML. But if you're not maybe comfortable with the declarative, so that's cool.
Yeah. So to get started with Fabulous for xamarin.forms, the dynamic one, you have the getting started documentation. So basically, you just need to install either Visual Studio or Visual Studio for Mac. And then you have templates you can install. So you can run .NET New Fabulous xamarin.forms templates. And once you have it, so I have already installed it, you can run the .NET New command line. So let's do that. Let's say we want to do a to-do list app. So we just execute that command. It will create a project. Once it's created, we can use our IDE to see the code. And you have, by default, you have 3 projects. So we have the shared project. So it's a .NET Standard 2.0 library where you will have all your code. And you have outputs project. So here, by default, you have Android and iOS. But we support also WPF, UWP, macOS, and GTK.
Oh, cool.
So all those are in the template. So you just need the correct flag you can find in the getting started documentation. So once we have done that, we can go to the code, and we can see that we find all those components. So the model, the message, the init function, the update function, and the view function. So we just need this little code snippet to run the actual application using the xamarin.forms application. So we just will bootstrap the Fabulous application. So okay, so let's debug this one. I will activate live update. So we have another component in Fabulous called live update. It's kind of similar of xamarin.forms auto reload. It will listen for changes in the source code and recompile the application on the fly and update either the device or the simulator. So if I launch the app.
So that's cool. So you're saying that this enable live update, like you said, similar to XAML hot reload, but will basically recompile your Fsharp code on the fly and see it updating. So it's sort of like a Fsharp hot reload in a way.
That's it.
Very cool. And of course, you're using Rider here, and you can use VS for Mac, VS on Windows, Rider, anything else that can build Xamarin apps. So if people haven't seen Rider before, it's a pretty awesome IDE as well. And that's why I love the .NET ecosystem. You can use whatever you want. So,
okay.
Very cool.
So the application launched. So we can see that we have a label, 2 buttons, and that we can interact with reacting. And all that is described by this view. So we can find the label with a count. So it's basically a binding to a label. We have a button that can dispatch messages. So here we say the command is dispatching in the increment message. So you declare all your view like that. And in your update function, you can see that for the increment message, we will change the current state of the application by incrementing the count with the step. So that's what we can see here. It's incrementing according to the state. So, okay, now let's try let's launch Larivière. So in the console output, it provided a command line to run. So Fabulous is a .NET tool CLI. So you have to install it. You have the command to install it in the documentation. But if you, let me first get in the correct folder.
Okay, so by default here, the live update isn't running, but you've enabled it, and then it
Yes.
output this little command to basically say, "Hey, run this command," and then it's going to start it. That's correct?
Yes.
Gotcha.
So you have to run it in the shared project, not in at the root of the solution.
Got it.
And then just press enter. It will start monitoring and waiting for changes.
It's sort of like .NET Watch in a way, like .NET Run Watch. Like, hey, I've started my application now. Watch for changes.
Yes.
Cool.
And make it interesting. Let's put a real application. So we'll just replace the code. So it's a 50-ish line of code for the to-do list app. And it gets recompiled and immediately appearing on the left.
Whoa. So you just took a bunch of Fsharp from another little snippet in VS Code, plopped it in there while the application was running, hit save, done.
Yes, and it's working. So if I say I want to do my laundry, I can add it. And it's fully working, so you can set it down and it will get remote. So the code for that is the model. So basically, we just need a list of string for the to-dos. We just want to track also what's currently written in the entry. And we declare all the possible events that will go in our application. So we can add to-dos, we can remove to-dos, and we want to track the text. In the init function, we will have the initial state of the application when it launches. So we have an empty list of to-dos. And for each one of the possible events, we will have the matching reaction. So if we have a given state and we receive this message, we will update. Here we will, for example, add the new to-do to the to-do list. So this one will create a new state that will be given to the view function, and we will recreate the entire UI with it. So that's what's happening here. So if we take a look at the review, we have a for loop here. So it's basically a for each loop in Fsharp. Let's say for each one of the to-do items, I want a text cell with a text equals at my to-do, and with a context action that will dispatch a to-do removed if pressed.
Oh, that's cool. So you could actually this is kind of nice. So there's not like an item template. It's like your item template is sort of in this for each loop. This that almost reminds me of like Razor syntax in a way. If we have any web developers watching, like in Razor sort of ASP.NET EU, for each through your objects and then return what each object is going to look like. So here you could, I'm assuming, apply business logic and say if the to-do equals, contains jogging, return something like an emoji, basically completely different.
Exactly. So you can definitely do that. You can put an if statement. Say if to-do equals jogging, then and you can just do that with an else statement, with an else. And we can say, for example, the text color, and let's say it's blue. So if I that way, so if I press that and I let live update the application, I can go and say jogging. And okay, jogging is not colored, and laundry will be colored. Yeah.
Wow, very cool. And you could and here you just change the color, but you could add an image. It could be something completely different,
Yes.
which is
Yes.
cool. Very cool.
Okay, so that was it for that application. One important point that's interesting is that given all those functions are functions, it means that for a given input, you will always have the same output.
Mm.
So it's really great for unit testing. We have an example here. So on the Fabulous repository, that we can unit test all the functions. So let's say I want to check the init function gives the expected state. I can just check that. If I want to check if my update function reacts correctly to a message, I can check that. And I can even check my view. So I can say, well, that's my state. You generate me the view for that state. And I can just check if everything is correct, if my label has the right value.
Wow, that's really cool. So when a lot of developers have to think about unit testing or even UI testing, here you sort of taken it completely out and said, well, it's always going to return the specific state, or it's always going to return this view to me, and I can just check the properties on it. That's really cool.
Yeah, James, can I jump in on that?
Yeah, go for it.
Yeah, not sure how the recording's working. Yeah, this is what I was kind of referring to at the start, that like everything just becomes information, right? The model is just information, and immutable, functional. You can just test it like this, and the view itself, just becomes a blob of information, and you can query it and find these elements and see what's actually there, and check their colors and check anything you want about them, and I love that. It's just that really captures what I was trying to say at the start.
Yeah, it's really easy to read logic and code, and it's very elegant. Like it's very much like, all right, this is the start, and then do this thing, and then here's what I think the thing is. Like it's going to do that thing, and it's going to return that specific state object kind of back to you, or stateless object in a way back to you, which is cool. It makes a lot of sense to me when you kind of see it, especially in a unit test too, which I think is very, very cool.
Okay, yeah. So to finish, I want to show you 4 existing applications written with Fabulous. So here we have Fabulous Contacts. It's basically a contact manager. So we have a list of contacts. We can add new contacts. We have validations. And we have a map too, where we can visualize the contacts. Mm-hmm. So this application is a multi-page one. So you can on the repository you can find how to do that in Fabulous, and it's using a SQLite behind the scene. We also have Fabimols, which is a part of Xaminols from the xamarin.forms repository, which showing how to use shell. Where you have access to everything.
Oh, cool. I always need more monkeys. I'm just saying that I don't know why that's not the default tab. It's a little upsetting to me personally. I don't know who wrote that sample, but we can fix that later.
Some cat lover.
Yeah, apparently. I think it was Dave Britch. I'm going to blame Dave.
And then we have the Fabulous weather.
This looks familiar. This looks a little familiar. It's nicer, actually.
So you're showing how to use carousel view, indicator view, refresh view.
Oh, cool.
And that's it. And also how to use, that's actually interesting, it's how to use REST APIs with this application and type providers. It's a feature specific to Fsharp that makes it really simple to do.
Oh, cool.
And to finish, we have the solar system planets. So it's called the Fabulous Planets, where it's using Euro 3D to preview the planet in 3D.
All right. Awesome. I love it, Tim. It's a great little walkthrough too, not only to see just like here's file new, but here's how you can kind of actually use a lot of the built-in tooling, use the tools you're using, extend it, use all that cool stuff. Any final words from you, Tim or Don?
Just to say this, get involved in project. This is absolutely a Microsoft community co-development. And part of the aim is to make sure the Xamarin ecosystem is full of interesting ideas about how things can be done differently. Here we're going right to the heart of the programming model, the programming language, and the whole approach. And we're just saying, yeah, the xamarin.forms components underneath are actually really good. They're, and we're using MVVM underneath. We're just putting this kind of functional approach to the descriptions on top of that hang around on top of this. And it's partly about the ideas and about making sure we can fuse the whole Xamarin ecosystem with ideas that really challenge and in fact, when you get that feeling like, wow, I never knew you could write UI anything like that, take that feeling and enjoy that challenge. Enjoy the fact that it irks you in some way. Enjoy the fact that it challenges you, like, why do I have to do things like I used to do them? Maybe there's variations on how we can do things. And one of the key things is that we make that real in Fabulous. You can use it for real. It's a community-driven project, not a Microsoft-supported project, but it is for real. You can go and deploy apps to the App Store using this today and do UWP and a whole bunch of other things as well. So enjoy both sides of that, innovation and delivery in reality, and come and get involved. It's really good fun. Tim is being an amazing primary maintainer for the repo. Absolutely wonderful that he got involved and has done incredible leadership on that work. So actually come involved and be a co-leader with Tim and myself and the others involved as well.
Awesome. Yeah, I love it. I love all the amazing projects, and especially as really seen this from the very early days when you very first showed it to me, to see where it's at today is absolutely spectacular. Tim, Don, thank you so much for joining me, showing off like a whole spectrum of everything. We'll have you back on to even go deeper on all the fabulous stuff in a future episode, so stay tuned for that. And of course, subscribe, ding the bell, do all the things that you want to do. Thanks for watching, everyone. I'm your host, James Montemagno, and have a good one.
Hey, James here. Just wanted to check in and thank you for watching this video. Now do all the things that you want to do, such as like, subscribe, and ding that notification bell. Become part of the notification squad. While you're here, check out all these awesome videos that I've already recorded. Click on that thing. Click it. Watch it. Do it.